Guys. Um, like I said, I do the exponent stuff, which has a bunch of math in it, obviously. Then I take a little bit of a break from it because exponents tends to overload you guys. Like that last question I showed you, negative 3x to the negative 2, all to the negative 2. Even though that's only 3 laws, it seems heavy, yeah? So I like to take a break from exponents for a little bit and just get away from it for a second. Today's lesson has almost no math in it, but it's got a lot of vocabulary. And while it's not super important to Math 10, it becomes more and more important as you go on. So this, for most of you, will be your first introduction to the proper names of the groups of numbers that we use when we do math. Okay? And like I say, as you go further and further in math, and every one of you has at least one more year of math ahead of you. Some of you have more, especially if you're planning to do anything in the trades or anything in the sciences. You're going to have a lot of math ahead of you still, and you're going to need to know what these words mean. Okay? So we're going to start with what we call how we count. And we call it, I've got it right here in bell-bottom laser font, the real number system. Real meaning because we can actually define all of them, okay? The reason we call it the real number system is because there's a whole separate number system which are called the imaginary numbers. You don't need to write that down because you are never going to deal with them unless you take calculus at university. But a lot of kids ask, well, why do we call it the real number system? Why don't we just call it the number system? Well, it's because there's this whole other number system called the imaginary number system. Okay? And those only exist to do math that we can't explain. So let's go ahead and talk about all of these things. The first group we are going to talk about is the natural numbers. And the natural numbers are the smallest group. And when I say smallest, I'm going to put it in quotes because it's not actually small. Okay? And here's what I mean. If I asked all of you, pretend we were in kindergarten, and I said, okay, class, let's count. And I went like this. Go! What would be the first thing you would all say? You're actually right, Connor. Some kid in the class would say something like that. You're absolutely correct. My son would have probably been one of them. In case any of you didn't hear, Connor said banana. But yes, you would all say 1, wouldn't you? Is 1 really the first number? No, of course not. What's the first number? 0. But nobody starts counting with 0, do they? When you have a baby, or you have a little baby in your life, your mom has had a new infant. For the first 12 months of that baby's life, how old is it? 0. Does anybody ever say 0? No, of course not. They count in months, don't they? Oh, he's 6 months old. And then there's that awkward time where you don't know when to stop counting months, right? All of you have had babies in your lives. How old's your baby? Oh, 23 months. Your baby's 2. How old's your baby? Oh, he's 36 months. Your baby's 3. You can stop doing it. For me, I would be 504 months old. I know it's a blue screen because all of you went dark. I'm trying to stay calm. It's a new tactic I'm going with, Wyatt. How's it working for me?
It's working pretty good.
Thanks, man. Now my screen says, do you want to reconnect?
No.
And the question, of course, should be, why the hell wouldn't I? Did I unconnect it? Obviously, I need it connected, but see how calm I'm staying?
Robert, that doesn't work, Robert.
It works. You just have to turn the pencil.
That didn't work.
It works fine. You just have to turn the pencil. Now, as I was saying, I am 504 months old. Actually, May, June, July, August, September, and we'll call it October. I'm actually 510 months old. which is always a gag I do when I meet a new baby and the baby is over 2 and the person gives the months. I always say, oh, really? I'm 500 and X months old. And then they never get the joke. They just think I'm being an ass. I don't know why. Anyway, it is the smallest group. I like to call them our counting, not with an A, you idiot. Counting numbers. So if I said, let's count, we'd start counting. And they go from 1, 2, 3, up to what? When do we stop counting? When we don't know the numbers anymore. But what number do we, what concept do we say we can count to? Infinity, right? So that's why I put smallest group in quotes. It's still an infinite number of numbers. Everybody cool with that? Now, one of you said there's 10, right? You're absolutely right, because we count in base 10, don't we? We count 0 to 9, and then what's the next number? 10. And we write it as one group of 10 with 0 left over. And then we start counting again. One group of 10 with 1 left over. That's 11. Until we get up to 19. And then what do we get? 2 groups of 10 with 0 left over. That's how we count. Now, oddly enough, that is not the most widely used counting system in our world. Does anybody know what is the most widely used counting system in our world? No. This is base 10 because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 10 numbers. So it's base 10. We use all 10 digits. Does anybody know what base is the most common one? No. It is base 2, which uses 0 and 1. Does anybody know why that is more common? Jordan. Yes. Computers talk in binary. Yes or no. That's the only thing a computer can do. So every piece of computing equipment you have uses yes or no. Which is why if you look at your power switch on anything, you see it's got a 0 and a 1. That's not input output. That's not an I and an O. That's not on and something else. That's 0, off. 1, yes, on. Cool? Not really cool, but kind of neat to know, I think. And of course, we can count in any other base as well. Security is often done in base 7, hexadecimal, which you have seen if you have played with computer security settings anywhere. All right, so we're cool with that? Okay, so that's the natural numbers. I'm going to highlight them because that's one of the terms you need to know. Now I'm going to highlight the next one, whole numbers. Now whole numbers is a problem because when I say whole numbers, you all already think you know what they are, right? You think that they're numbers without fractions, yeah? But not quite. The whole numbers are the natural numbers. So it's all natural numbers plus 0. So 0 isn't part of the natural numbers, but it is a whole number. So they go from 0, 1, 2, 3, up to infinity. Everybody cool? They are exactly one number bigger than natural numbers. And that one number is 0. Okay? I don't know if you're going to have sound on this recording until now because I just plugged in the microphone. I can't remember. At one point, I disabled the Surface microphone, and then I did a whole lesson without my big microphone, and then I realized there was no sound. and I was going to re-enable the Surface microphone in case I ever did that again, and I can't remember if I re-enabled it or not. So either you will have crappy sound quality up till right now, or you will have no sound up till right now. It's one of the two. We'll find out in a moment. Anyway, everybody understand? That extra number, that's the one difference. Everybody cool? All right, so now we get to our third one, integers. Integers are what? Anyone know? What haven't we talked about yet? No. We've talked about 1 to infinity, 0 to infinity. What's missing? Negatives. Integers are all the whole numbers, which means they're also all the natural numbers, plus negatives. So it is negative infinity up to 0 up to positive infinity. Everybody cool with that? Okay, so now you guys are being such smart children. We get to rational numbers. What's the only thing we haven't talked about? We've talked about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. We've talked about 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. We've talked about integers. Negative, blah, 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 blah. Negative 1, negative 2, negative 2, negative 1, 0, 1, 2, 3, blah, blah, blah. What haven't we talked about? What's missing? Haley? Decimals. Absolutely correct. Rational numbers are all the decimals and fractions. Now, I want you to put a little star by decimals, and I want you to underline fractions. And this is why. A rational number is anything, and I'm highlighting anything, is anything in this form. X over y. Any fraction is a rational number, okay? But there's some rules. X and y are integers, and y cannot equal 0. If x and y are integers, they fit into this box, and y isn't 0, you have a rational number, okay? Now there's something else I want to highlight here, and Haley said it. None of these numbers, from natural, whole, or integers, there are no decimals and no fractions. And that's why I said whole numbers gets confusing. Because up till now, if someone says a whole number to you, you just mean there's no fraction. But now you know that whole numbers are actually this, and integers are something else. Everybody cool up till now? Okay, now I'm going to explain why this decimals has a star. This fraction, what we call a fraction, but it's really a rational number. What math is happening there? Division. That's x divided by y, right? And if I do that with my calculator, some of those work out perfectly, don't they? What's 1 divided by 2? 0.5, right? What's 25 divided by 100? 0.25, right? It ends. It's pretty. It's nice. Yes? What is 1 divided by 3? 0.3, 33, 33, 33. For how long? Ever and ever and ever. And that's a problem because is 1 over 3 a rational number? Is 1 an integer? Yes or no?
Yeah.
Yeah, because it's in everything. Is 3 an integer?
Yeah.
So 1 over 3 must be a rational number, yes? But when I do that on my calculator, I get a weird decimal that goes on forever, right? So the reason decimals has a star is because the decimal must terminate. What does terminate mean? End, not destroy. Not, I'll be back. Not that kind of termination. Must terminate or repeat. So, when it terminates, it ends. For example, 1 divided by 8 is 0.0625. It ends. Everybody cool? 1 divided by 3 is 0.33333. It repeats. Everybody good? 1 divided by 9, 0.11111, forever. 1 divided by 8, 0.0625. Everyone's good, yes? Okay. Now, that covers all the numbers that you're used to, right? And there's lots of examples of these in your lives. Many of you have heard the joke I do where your parents first taught you fractions. Your parents all taught you fractions by doing the same thing every parent does now. When you do something bad, they start counting. Right? 1, 2, and then you do what they ask you to do because you don't know what's going to happen when they get to 3. Until you realize that I don't want to clean my room. And your mom goes, 1, 2, nope. And then your mom also doesn't know what to do when she gets to 3. Because your mom's not allowed to do anything to you anymore. Back in the day, if your mom got to 3, what would have happened? Yeah, you would be slapped up the side of the head. That's not allowed to happen anymore. So your mom doesn't want to get to 3 either. So what did she start doing? Or 2.5. And then you're like, holy crap, what is this half garbage? And then you were scared. And then it worked for like a week or 2. And then your mom was like, 2 3/4. Oh my God, what the hell? Another, right? That was how we all learned fractions. If your mom was good at math, how long could she keep counting before she got to 3? Forever, right? 2 3/4, 2 7/8, 2 15 16ths, 2 31 32nds. Right? She could go on forever because she could always cut it in half if your mom was good at division. My mom didn't bother. My mom didn't even count. Go clean your room. No. There was no 1, 2, 3. We didn't get counting. My mom wasn't as bad with it, though. My dad was much worse about it. If Dad had to come down and tell us to clean our rooms, it was already too late. Because if Dad actually had to get up out of his chair and come downstairs to the basement where our rooms were, it was way too late. But, times change. So that's how we all learn fractions, right? Did anybody not have the counting thing growing up? You never were counted at?
No, my mom used my middle name.
Oh, middle names. So do you have more than one?
Alexander.
Do you have more than one? That's why I gave my kids 3 or 2 middle names. Because, yeah. So it was St. John, nothing. St. John Xavier, nothing. St. John Xavier, Charles Myers. But then, of course, like counting, he understood, what am I really going to do? Right? You're grounded. Oh, I get to stay in my room with all my toys? Okay. Damn it. You're grounded to the dining room table. The dining room table is near the television. He could hear it. So let me get this straight. I'm going to sit here and listen to TV. You're grounded to the backyard. Okay, where the trampoline is. Gotcha. You're grounded to the bathroom. That kind of would have worked, but then what do you do when you got to pee? We only have 2 bathrooms in the house. I've got 2 kids. If they were both grounded, where do I pee? Right? You're grounded to my room. Your room has a better TV than out here. In the bathtub with a snorkel. Stay underwater until you turn into a raisin. Anyway, actually my son used to do that too. He would practice holding his breath. I've told you this story. I came into the bathroom once. He was face first in the bathtub. What the hell? Grab him by the hair. Dad, I'm holding my breath. And then he would do it at lifeguards in pools. He'd dive off the diving board and sit on the bottom for like a minute. And the lifeguards would get all twitchy.
At this time of grade 10, that
Any of you need pictures?
Not here on full day.
Get going.
Want to retake their order form. Bring your photo package down.
All right. Okay, you guys are smart kids. What's the only thing left? What's the only thing we haven't talked about? We've talked about every number, every fraction, every decimal that ends or repeats. What's left? Irrational numbers are the decimals that don't end or repeat. And what's the most famous one? Pi. Because pi is the circumference divided by the diameter, right? That looks like a fraction, doesn't it? But it isn't. It never repeats. Does anybody know of any other irrational numbers? Aaron. E, which you guys won't study until grade 12. When did you guys do E in Mexico? Never? You just know it? Okay. E is another one. If you look at it on your calculator, you will find a button that has E and an X. It's another irrational number. Anybody know of any others? No? Okay. All the rest of them, 99% of the rest of them, are square roots that don't work. For example, what's the square root of 2? If you punch into your calculator, what comes up? No, not an error. Tell me what comes up, Wyatt. 1.414. Keep going. Does that repeat? No. Does it end? It ends because your screen ends. But if your screen went on, what would happen? It would keep going forever and ever 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 and ever. Infinite amount of decimal places with no repetition. Okay? Now here's the thing. On your calculator, that ends, doesn't it? Right? But it doesn't end in real life. If your calculator screen fills up, it is most likely an irrational number. Okay? Now, this is weird for you guys because we just did trig, didn't we? Right? And in trig, when we were doing sine and cosine and tangent, didn't our calculator screen fill up? Didn't it? But isn't sine just opposite over hypotenuse? And isn't opposite over hypotenuse just a fraction? So even though your calculator screen was filling up, it was still a rational number. Everybody cool? So you got to understand the difference here. Sometimes your screen's going to fill up and it's an irrational number. Sometimes your screen's going to fill up, but you have to know if it's rational or not. And I'll give you an example of this. What happens on your calculator if you do 2/3? Is 2/3 a rational number? Is that a fraction? Is 2 an integer? Is 3 an integer? So this is a rational number. But if you do 2 divided by 3 in your calculator, what shows up? I'm interested to see. Some calculators actually show that. Good. What does yours show, Wyatt?
0.66666667.
It ends, it does 666 out to the end, and then it rounds to 7.
Yeah.
Right? Now, does that look like repeating? It does. 666666667. The 6's repeat, but then there's a 7. Right? So if you don't know what your calculator's doing, what you could, based on this definition, say 2/3 is an irrational number, couldn't you? Even though it obviously isn't. Is everybody cool with that? All right, I'm going to shut up. You guys are going to do 1A right now. Turn the page over. Do 1A right now. You're not going to be able to do B for a moment. Well, some of you might know B. Who can remember how to go from a decimal to a fraction? Can anybody remember how to go from a decimal to a fraction? Yep. Why is it 3/25? You have one of those calculators where you can put in a decimal and hit SD and switch it, right? Excellent. Is that doing math? No, that's pushing buttons. If I had enough bananas, could I train a monkey to do it? Yes. So you're not doing math. So let's talk about how you do this with math. How do I convert that to a fraction? It's 12/100, yes? Why? Because I remember grade 3 place value, right? Tenths, hundredths, thousandths. So that is 12 hundredths, right? If it's 12 hundredths, it's 12/100. And Mrs. Bag Crumble would never let you write that, would she? Because that simplifies. You can divide that by 4 to get 3. You divide that by 4 to get 25. Everyone remembers that, yes? Excellent. Does everybody remember what that line means? That what is under that line repeats. So this is really 0.111 forever, yes? Now, if it was only 0.1, what would it be? 0.1 would equal 1/10, yes? But this is 0.11111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111or slightly bigger than 0.1? Very slightly bigger, which means if it's going to be a rational number, it must be one of something. The bottom number has to be an integer, doesn't it? Doesn't it? Okay, well, the integer, if it was 0.1, it would be 10. What, as a denominator, is the next integer that's slightly bigger than a tenth? What are the integers beside 10? There's two integers that are beside 10. What are they? 9 and 11. Which one is slightly bigger as a fraction? A ninth or an 11th? A ninth. So this must be 1/9. Does everybody understand why? Okay. Do you all agree that 0.111 is slightly bigger than 0.1? You all understand that 0.1 is 1/10, yes? You all understand that as a fraction, these numbers have to be integers, right? So the denominator has to be an integer. So I need the next integer that's closest to 10. 1/11th is smaller than 1/10, right? 1/9 is bigger than 1/10. So it has to be 1/9. Everybody cool? Now you guys are smart kids. If that one repeats and it makes us go over 9, and it happened once in math, what do you think 0.12 repeating is? 0.12 was 12/100ths, right? So what do you think 0.12 is? So it's 12 over what? 99. Because that's slightly bigger than 12/100. Is everybody cool? What then would point 1, 2, 3 repeating be? Use logic, you guys. You're smart kids. 123 over what? Over 999. Because if there was no repeating bar, it would be 123 over 1,000, yes? Everybody cool? All right. Now look at C. What does C mean? What do those dots mean? That it keeps going from where? It's going to keep going as 2's, yes? So this must be what? 2 over what? Do I need that many 2's? No. So it's 2 over, somebody whispered it. What is it? Just 9. You only need the 1 9. Because the 2 repeats. Everybody cool with that? All right. Now look at D. D is very tricky. What repeats? The 5, the 4, or both? Just the 4. You guys are smart kids. A repeater means it's got to be over 9, yes? Because point 1 was over 9, point 2 was over 9. So the 4 must be over 9, yes? Does the 5 repeat? No. The 5 doesn't repeat, does it? So what number do you think I should put on the bottom? Because I need more than one number down there. I can't put it over 9. I can't put 99 because that would be 2 repeaters. What number do we use in math to show nothing? 0. So this would be over 90. Now, how do we do the top? If it was 5, 4, it would just be 54, wouldn't it? But the 5 doesn't repeat, does it? The 4 repeats. So if you go to your calculator, you do 54 divided by 99, you get 545454. We knew that would happen based on what we've done, yes? But I don't want 545454. I want 5444, right? Right?
Yeah.
So the 54 is what I have, but the 5 doesn't count, right? So what we do there is we write what we have minus what we don't care about. So we get 49 over 90. And if you do that, you will get 0.544444. Everybody cool? So let's do this one. What if I told you it was 0.1, 2, 3, and only the 3 repeated? What would it be over? How many 9s do I need on the bottom? There was 1 repeater there, so I had 1 9 on the bottom. There was 1 repeater there, so I had 1 9 on the bottom. How many repeaters do I need? 1. So there's a 9 on the bottom. What else goes there? Zeros. And then what goes on top? 123 minus what? How much? 12. Which would be 111 over 900. And then if you check that with your calculator, you get 0.1233333. Everybody good? All right, your homework tonight, and it is so little, it's embarrassing. Page 86 and 87. If you can't remember how to do things like root 3 on your calculator, just don't do it. Okay? You use your calculator for all of this. And please notice, all you have to do here is categorize the numbers. So there's only 5 things you can write there, right? Natural, whole, integer, rational, or irrational. That's it. For that whole page. And it's almost the same for 87. Everybody good? That's it. That's your only homework.